Okay, guys, quiet, please. Thank you. Let's review. Okay, guys, thank you. All right, so conditions for triangle similarity. So we've talked about, guys, I'm talking now. Thank you. So we talked about triangles being similar. Hey, guys, enough with the mints. Thank you. All right, so we talked about proportional sides, corresponding angles being the same. So what would make two shapes similar? There are really just two things to consider. If, let me do a text box. There we go. If all corresponding angles are congruent, let me fix that. Let's try that again. There we go. If all corresponding angles are congruent, or we could say this. The ratio of corresponding sides are the same. Or the ratios, because it's more than one ratio. So that's really it. That's what constitutes similarity. Similarity means not the same size, but the same shape. So for example, if I were to give you two right triangles, this is a good example. Say that's 3, 4, and 5. So this is an example. And then I did a bigger one. I'll do it in green. Like that. I'm trying to do a scale if I can. So that's like 6, 8, and 10. So notice how every side, corresponding side, has the same ratio. 3 to 6, 4 to 8, 5 to 10. Also notice they both have right angles. And of course, I'm going to trust that this top angle is the same as this top angle, this bottom angle is the same as that bottom angle. So that would constitute similar shapes. They're not the same size, they're not the same thing, but it's scaled up. I just took the blue triangle and doubled in size. That's what I did. Now, how do you conclude two shapes are similar? So there's a hypothesis or a conditional that we would write. You could say if all corresponding angles are congruent, or you could say this. All corresponding sides are proportional. So in this unit, we're starting to venture into proofs. So proofs, like you see the posters off to your left over there, where you have like a 2-column proof, you have statements, you have a reason. We're going to be doing that eventually, yeah. And actually, you guys are doing proofs right now in your project, right? Where you have to prove like, oh, why does my shape a square? You got to tell me, oh, it's all sides are the same. This sides are, foreign right angles, right? So you have to like find the distance, you have to find the slopes. It's the same thing that's happening here. You have to get in the habit of like proving your statements. So, okay, all corresponding angles can, and we're going to get in the habit of abbreviating because trust me, you're going to get really tired of writing this stuff out. Like if you had to write all stuff like this, I think you would really despise this process. So we want to get in the habit of abbreviating all. So CRR, corresponding angles, corresponding sides proportional. If that happens, the figures are similar. Okay. So now let's move on to, so questions so far? Okay. No, all right. So let's keep moving. So let's go ahead and read the next part. Faith, can you read where it says today?
Today we will focus specifically on triangles, a very powerful geometric equation. If you want to prove these triangles similar, you need to show every angle is congruent and every step and every set of sides is proportional. That will be 6 steps. Are there any shortcuts?
So the answer to that first question is no. Are there shortcuts? Yes. Definitely want to use shortcuts. So let's look at 349. Peter, can you read 349 versus Scott?
Yeah, Scott is looking at that fig's outright. He thinks that angle EFG,
Mhm.
angle HIJ, but he is not sure that the shapes are drawn to scale.
All right, so that little tilde sign or squiggly line is called similar. So when you read it, you'd say triangle EFG is similar to triangle HIJ. All right, thank you, Peter. So are the corresponding angles equal? Convince Scott that they are similar. Well, here's what I would do. I would kind of redraw HIJ. I kind of sort of just tilt it kind of like that a little bit. Okay, not my best drawing. HIJ. And J is, of course, 87 degrees. So I'm going to put an 87 right here. And H, of course, is 68 degrees. So if you think about it, what would have to be reserved for angle E? So right now, if you look at the first triangle, the EFH, or sorry, EFG. So you have 87 and 25. What does that add up to? 87 plus 25? Let's say 87 plus 20. 112, good. Not quite. You're almost there. 112. So how much is left over for E?
68.
Good. And guess what? I do see a 68
There.
next to angle H. Correct, right. And if I look at the green triangle, the HIJ triangle, if I have 68 and 87, that adds up to 145. That's definitely 25. So really, when I think about it, well, yes, they are equal. How many pairs of angles need to be congruent to be sure? So to be sure, do I need all three pairs, or is only two pairs enough? Just two. Yeah, all you need is two pairs. Like once I knew A7 and A7 and I could find, oh, then this other one's 68, then it's good enough. Then I'm good. So how can you abbreviate this condition? We call it the AA similarity theorem. So AA, you draw like that. You put two A's and a little tilde sign. So that indicates angle similarity. So it's almost like a language if you think about it. There's a lot of shorthand notation, and we're gonna do it because again, you're gonna drive yourself nuts if you write angle similarity. If you actually write out all those letters, that's just crazy. We don't want to do that. So are other shortcuts? Yes. Let's move on to the next page. All right, here we go. I'll skip that. Actually, let's just go on with that demonstration. Let's find out. What's happening. It's there for a reason. So okay. So that's annoying. And this doesn't want to respond. Well, you see that E and B go together and D and A go together. And I don't know what the heck is going on here. But we do see its sides are proportional. So I'm assuming this is a slider. Oh, there we go. Okay. Just being slow. Yeah, so the thing is that even if I change angle D and A, it doesn't matter because the other angles will change. The E and B stay fixed. So as D and A change, F and C will correspond or react to it. And even the corresponding sides, like EF to BC, will still be an 8:10 ratio because ED to BA is also 8:10. Or if I even do this, nothing really changes. So yeah, so we see that this is I think this is angle similarity. So that's just a little demonstration we've gone with that one. Here, I'm guessing it's going to be with all sides. This side angle side. So notice that you're given a side, an angle, and a side. So 4.4, 42, 4.39, 7.26, 42, 6.58. Notice the ratio between 7.26 and 4.84 is 1.5. Notice the ratio between 6.5 and 4.39 is also 1.5. And notice the angles in between them are the same. So even if I change the angle, okay, this is just really slow. Let's try again. Let's turn it off. Here we go. Yeah. Even if you change that, the sides don't change. The sides are still proportional. So you still get similar triangles, regardless if you change that. Or if I even do the scale factor, it doesn't matter. You still have similar triangles. They're still going to be, and everything's going to be in the same ratio. So not the best demonstration, but here's the conclusions. I'm going to type this up for you guys. So AA similarity. Ooh, I got a little tilde sign. Very lovely. Asimilarity means if two angles in one triangle hold on. I don't like how this is written. If two pairs of corresponding angles between two triangles are congruent, and I'll accompany that with the diagram. Okay, again, not my best diagram. Yeah, so let's recap this. If two pairs of corresponding angles between two triangles are congruent, so this corresponds to this corresponds to this, and congruent, then the third angle is also congruent. This makes the two triangles similar when that happens. So that's called the AA similarity theorem. Now, there's another one. I'll change colors, so we'll keep it in blue. It's called the SSS similarity. And what that means is that if all three pairs of corresponding sides are proportional, meaning equal ratios, then the two triangles are similar. So I'll give you another example. What if I have this here? I'm just totally making this up. What if I have like 2, 3, 4, 4, 6, 8? So these would go with that. Where this goes with this. Okay. So that's another we call it a theorem. Another thing we can consider. Lastly, we'll go green. SAS similarity. What this means is that if two pairs of corresponding sides are proportional and the angle in between, them are congruent. Angles. Then the triangles are similar. All right. So how's that look? It'll look kind of like this. So what if this were like, say, 4 and 8, 6 and 12. Yeah. So notice that the sides are proportional, 1 to 2, 1 to 2, and the angles of 2 are the same. That's side, angle, side. Side, angle, side. Side, side, side. Angle, angle. There's rhyme and reason to these. Yeah, there's actually some rhyme and reason to it. And so this one goes with that one. So I'll take a moment to kind of simmer on that a little bit, ask questions. We'll use this for 351. And then after that, I want to kind of get a feel for how you guys are with the project, because I don't think we necessarily need to go over the next page. Maybe I'll summarize it, and then the rest could be stuff we could do another day. So,
Will there be writing on the test,
oh yeah,
like a lot?
maybe. I don't know. Let me talk to Davis about that. I think, yeah, we expect you guys to know that. Yeah. I know.
I don't.
Yeah, we'll practice it. Yeah, we always start you kind of easy. We kind of like give you like a partial fill out proof, and then we eventually work our way to where you start doing it all on your own. So, okay, again, sorry, guys, quiet. Similarity, side similarity, side angle side similarity. Those are the 3 similarity theorems for triangles. When this happens, you could say that these triangles have the same shape, but not necessarily the same side. Okay. No, those are the 3. For similarity, that's it. You're thinking of congruence, maybe. There's congruence. There's like, I think of like side, angle. Yeah, we'll get there later. For similarity, yeah. Okay, so here we go, guys. Let's take a look at 351. So if someone can read the instructions, Connor, can you read the instructions for 351?
Based on your conclusions from problems 349 and 350, the side of the
Mhm.
pair of triangles below is similar. They are similar, describe a sequence of transformations that carry one onto the other. Explain your reason.
Okay, so let's look at part A. We probably want to find the missing angle. So angle P, so if that's 84 right now, that's gonna be 96. Oh, I see a 96 there. So this is probably gonna be 52. So the answer is yes. And that's gonna be AA similarity. Even though you weren't directly given 2 pairs, but we eventually found the 96 there, so it was good enough. Now let's look at B. 14 over 44.8. I will definitely need a calculator. Cannot do that in my head. And we can do that in my head, be incredibly impressed. 2064 and lovely. Since I had calculators, you never brought back. Those pre-Cali B honors students.
Wait, can I make a guess?
Yeah, guess who this? Yes,
Wait, maybe.
they're both juniors.
Oh.
Both juniors.
14 divided by 4.
Oh, I thought who's someone calculators.
Gonna guess that.
I thought, yeah, that's more fun.
Boys or girls?
1 boy, 1 girl, actually.
Can we have a hint?
One's very tall and plays basketball. He's from Spain. Yeah. And the other one actually, I'm a little surprised, but she probably just forgot. She plays volleyball. Sadie Kohler. Oh yeah, that's good. Tell her to bring back my calculator.
Yeah.
Oh, sorry. Okay. Sorry about that. Can you do the next one then?
Tell Sadie when she's
Good.
playing. Give back the calculator.
Okay, and the angles are the same. Guys, quiet. The angles in between are the same. So yeah, that's side angle side. Side angle side similarity. So that's how you could prove it, because as long as you can prove the sides proportional, which I can with the calculation I just did, and the angles between are the same. Now, one thing to caution you about, let's say I didn't have this, right? Let's say I gave you this instead. That's not side angle side. That is, that guys, need you to focus. That's side angle. Or if I'm gonna be funny about it, ASS, so don't be an ass. You get that? Doesn't work. SSA could say ASS anyway, sorry. But but it has to be in between. Very, very important, guys. It has to be in between, okay? That all good. Correct. Correct. Okay. Okay. Try to code more here. And then I want to ask how the project's going after these last two. Okay, for part C. Okay. Actually, this is gonna be a yes. It's not terribly obvious. I'm gonna break off the little triangle and compare it to the big triangle. So NMH
I know. That's our, like,
SML. That is the same as that because you're told so. Now, think about it. Both of these angles, we call it the vertex angle because it's the top angle. Both these top angles were shared, right? Wasn't this identical to this because they pretty much were overlapping each other, right? For the most part. So I definitely angle M equals angle M would have to be. So do I have enough to say they're similar? I do. Angle similarity. Yeah. Can you get? Yeah, it's a visualization thing. That's why I have to pull out the triangle and compare it properly. Okay, last one. Yeah, Connor, go ahead.
On this one, since the angle at the top is the same for both, the angle on the front side is the same, and it's.
Correct. Well, I didn't know if it was isosceles right away, so I couldn't say that. But actually, I don't know if they're isosceles, to be honest. But right, you do see that there's something shared. So okay, last one. All right. Small to small, medium to medium, big to big. Okay. So let's compare 18 and 90. I don't know, what was that? That was kind of weird.
Peter?
That was Lucas.
That was Lucas, I heard it.
It's literally giggling.
Hey, guys, this is all being recorded too, just so you know. Okay. All right. I can share it during parent teacher conferences next week.
Next week?
Yeah.
The open house.
Yeah, no, this year's flying by.
Yeah.
You get Friday off next week.
And Friday off.
Friday of next week.
I've been logged in trying to do my.
Yeah, you tell him, Peter. All right. So guys, what's happening here? Tell me. Talk to me.
I just feel like it's like a skill factors happening.
It's the SSA.
SSA.
Because all the
No,
time-
no, 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 no.
I meant it's 3S and then. it's-
Okay. Okay, guys, I need you to focus. All right. So when I compare small to small, medium to medium, big to big, I got the ratios. Fine, I got 0.2 for the small to small, but medium to medium was not 0.2, it's 0.217. The big to big, right?
So no.
So the answer is no. Even though it kind of looks like it, you can't go based off looks. You gotta be precise. So don't go based off looks. That's very superficial.
Make sure that love.
Okay.
For C, right?
C was yes. You know because it's not enough. No, this is okay because I have two pairs of beams are the same. All right, now to get a heat, yes, the foot.
Oh, I wish I was on.
Okay, guys, I can't hear. You guys are talking, but 0.277. Now, just a quick heat check. How are you guys looking at the project? Are you guys done or need more time? Go for it. Go for it. Right. I want, we'll do the rest of these notes on Thursday.
And there's just pretty good doing this.
There's gonna be homework though. I'm gonna print it while you guys are working.